Okay, so random variables. Random variables are quite important. So, okay, let's see. I'm just gonna give you the definition straight up. So what it is a random variable is a function that maps an outcome to a numeric value. So what just happened? You know, what was that? So let's just go to the board and explain something before we proceed. So you've got two things going on. You've got events, sorry, events, and you've got outcomes. Okay, so an event is just rolling a dice. You just roll it. The action of rolling a dice is an event, and then an outcome, essentially what that is what you get when the event happens. So for rolling a dice, you have 1, 2, 3, 4, 5, 6, right? So you get this outcome, and each of these outcomes, they have some probability associated with that, right? Okay, so a random variable maps some outcome, so one of these guys, so some numeric value. So for example, the obvious thing would be to do is say, okay, this outcome corresponds to x is going to be 1, and then this outcome here corresponds to x equaling 2, and so on and so on. So those are random variables. It may just, it may just be like, oh, it's just 2 and it's just 1, but we need a bit of rigor. So we need to say, okay, this is a random variable. So x equals 1. So that's that, and then we can talk about probability. So the probability that this random variable here, which takes an outcome and makes a numeric number, is in some set A, denotes the probability that x falls in some range A, right? So yeah, so some range A. Now yeah, so, and we often, it's always, not often, always, like, shorten. We just take this out because we always know it's a function of outcomes, and we say, okay, x is in some range A. Now the thing is that okay, so actually let's just go on with the example and explain the little thing you may be a bit worried about. Okay, so example. Here's the example. So let x be a random variable, and it is the winnings on a $2 bet on an even dice roll. So you go to a casino and you say to the dude, you know what, I'm gonna wager $2 and I want you to roll a dice, and if I roll a dice I get $2 more, but if and the dice is even, I get $2 more. But if you roll the dice and it's odd, you take my $2. So you've got this is what it does. So a random variable maps these outcomes, so the odd outcomes, 1, 3, 5 to -2. So it means you're negative money or whatever. You lost money. And the random variable maps 2, 4, 6, so an even roll, to 2, so +2. So you win some money, and we can express that like this, right? So we can work out things like probabilities. So what's the probability of x being 2? That's just going to be a half, right? Because there's 50% chance you get one of these outcomes, which corresponds to a win, which is 2. Yeah, and you've got the exact same thing, like, because it's 50-50, so the other possibility has to be 50. Now you might be confused as to, like, why are we letting x here be 2, and like it equals 2, and then x here is just some range. Now it's to do with like discrete versus continuous random variables, because okay, so here you can think of the range. So I say x falls in some range A, right? So the range here is just the number 2, so it's just one single point. That's it. It's just one single point. And so you can say, x is in. You can say things like this if you really want. You can really want. So let's scroll down a bit. Okay, so you can say, okay, what's the probability x is in the set 2? That makes sense. But you can say this. So if it's just going to be like one number or something, say what's the probability x equals 2? Yeah. Anyway, so that hopefully that clarification didn't confuse you. So again, this is a very technical video. Rewatch it if you need. We'll do some exercises soon so it sinks in. But next we're gonna go over probability mass functions and density functions, and then we have a funny example. Then we will go in some exercises to really help consolidate your understanding. Okay, I'll see you soon.